Imagine this. You're a farmer staring at a field that's supposed to be feeding your family, maybe even your whole community. But year after year, the soil gets worse. Crops get smaller. Yields drop. You've tried everything the experts told you: new fertilizers, better irrigation, fancy crop rotation systems, and still nothing works. Now picture this. The solution wasn't some expensive new technology or complicated chemical formula. It was 9 inches. Just 9 simple inches that changed everything. And if you stick around, I'm going to show you exactly how this worked, why nobody figured it out sooner, and what it means for the future of farming. But first, if you love stories about simple solutions to massive problems, hit that subscribe button right now because we dig into these kinds of mysteries all the time. So let's go back to where the story really begins. The Great Plains of North America. We're talking about millions of acres of farmland that were once incredibly productive. But by the 1930s, something had gone catastrophically wrong. The Dust Bowl wasn't just bad weather or bad luck. It was the result of decades of farming practices that nobody questioned, because, well, they seemed to work fine at first. Farmers plowed deep into the soil, turning over everything, exposing fresh earth to plant their crops. This was standard practice. This was what you did if you wanted to farm seriously. The logic made sense too. Break up the hard ground, bury the weeds, give your seeds soft soil to grow in. For a while, harvests were incredible. People thought they'd mastered the land. But here's what nobody understood at the time. That deep plowing was destroying something invisible but absolutely critical: the soil structure. See, healthy soil isn't just dirt. It's a living ecosystem. Billions of microorganisms, fungi networks, earthworms, all working together to create a matrix that holds moisture, stores nutrients, and supports plant roots. When you plow deep, you rip all of that apart. You expose carbon that's been stored underground to oxygen, and it burns off into the atmosphere. You kill beneficial organisms. You break apart the aggregates, those little clumps of soil particles that create air pockets and water channels. And worst of all, you leave the surface bare and vulnerable to wind and water erosion. The Dust Bowl was the ultimate consequence. Topsoil just blew away. Massive dust storms turned day into night. Families lost everything. Farmland became wasteland. And this wasn't just an American problem. Around the world, wherever industrial agriculture spread, the same pattern emerged. Plow deep, plant, harvest, repeat. And slowly but surely, soil health declined. Fast forward to the late 20th century, and farmers everywhere were facing versions of the same crisis. Yields plateauing or dropping despite using more fertilizer. Soil compaction getting worse. Water runoff problems? Erosion eating away at fields. The experts had solutions, sure, but they mostly involved spending more money, more chemicals, more machinery, more inputs. It was like trying to fix a leaking bucket by pouring water faster. Then some farmers started noticing something interesting. In nature, nobody's out there plowing forests or prairies, yet those ecosystems are incredibly productive. On the soil in an undisturbed prairie can be feet deep, rich, black, and full of life. So a question started forming. What if we've been doing this completely backwards? What if the plow itself is the problem? This is where those 9 inches come in, and trust me, once you understand this, you'll see why it's so brilliant. The solution was no-till farming, but specifically, it was about how shallow you could work the soil while still planting crops. Traditional plowing goes down 8, 10, even 12 inches or more. It flips everything upside down. No-till farming means you don't plow at all, or you only disturb the soil in a very narrow band exactly where the seed goes. That 9-inch difference, the difference between plowing down deep and either not tilling at all or only disturbing the top inch or two, that's what changed everything. But here's the thing. This idea wasn't new. Farmers had experimented with reduced tillage for decades. So why did it take so long to catch on? Why couldn't the experts fix this problem earlier? The answer is complicated and honestly pretty fascinating. First, there was a massive cultural barrier. Farming traditions run deep. If your grandfather plowed, your father plowed, you plowed. A clean, freshly turned field looked right. It looked productive. A no-till field, especially early in the season, could look messy, covered in last year's crop residue. It didn't look like farming was supposed to look. Second, the early equipment wasn't great. No-till requires specialized seed drills that can cut through residue and place seeds at the right depth without disturbing much soil. In the early days, these machines were expensive, unreliable, and hard to find. Farmers who wanted to try no-till often couldn't get the tools to do it properly. Third, and this is huge, the transition period is rough. When you first stop plowing, your soil doesn't magically transform overnight. It can take years for the biology to recover, for earthworm populations to build up, for organic matter to accumulate. In those first few years, yields might actually drop. Weeds can be harder to control without tillage burying them. For a farmer operating on tight margins, that's a terrifying risk. But despite all these obstacles, something remarkable started happening in the late 1980s and into the 90s. Farmers who stuck with no-till started seeing results that seemed almost too good to be true. Soil that had been hard and compacted became softer and easier for roots to penetrate. Not because of plowing, but because earthworms and plant roots were doing the work naturally. Water infiltration improved dramatically. Instead of rainfall running off the surface, it soaked in, meaning crops had more moisture available during dry spells. Erosion dropped to almost nothing because the soil surface was protected by crop residue acting like a mulch. And after a few years, something even more amazing happened. Yields started climbing. Not just back to where they were before, but often higher. Here's why those 9 inches matter so much from a scientific perspective. Soil is stratified. Different depths have different properties. The top few inches are where most biological activity happens. This is the zone richest in organic matter, where fungi and bacteria are most active, where nutrients cycle most rapidly. While when you plow deep, you bury this active layer under less productive subsoil. You're literally putting the worst soil on top and the best soil on the bottom. No-till keeps that biological layer right where it's most effective, at the surface, feeding your crops. Plus, by leaving crop residue on top, you're continuously feeding that system. As residue breaks down, it adds organic matter, which feeds microbes, which create soil structure, which holds more water and nutrients. It's a positive feedback loop. The carbon story is incredible too. Healthy soil stores carbon, a lot of it. Globally, soils hold more carbon than the atmosphere and all plant life combined. When you plow, you release that carbon. It oxidizes and becomes carbon dioxide. But no-till farming keeps carbon locked in the ground and actually allows soil to sequester more over time. Some estimates suggest that if farmers worldwide adopted no-till practices, agricultural soils could offset a significant chunk of global carbon emissions. We're talking about a farming method that's better for the farmer's bottom line and better for the planet's climate. That's rare. Now, you might be wondering, if this is so great, why isn't everyone doing it? Well, adoption has actually exploded. In places like South America, particularly Brazil and Argentina, no-till is the standard. In the United States, no-till and reduced-till systems now cover tens of millions of acres. But there are still barriers. In some climates, especially cooler, wetter regions, no-till can be trickier. Now, the soil stays colder longer in spring, under residue cover, which can delay planting. Wet soils can be harder to manage without tillage to dry them out. And there's still the weed problem. Without tillage, farmers often rely more on herbicides, which brings its own environmental concerns. This is where the story gets even more interesting, because the 9-inch solution opened the door to even more innovation. Farmers practicing no-till started experimenting with cover crops, plants grown not for harvest but to protect and improve the soil between cash crops. Species like clover, radishes, and rye can suppress weeds, fix nitrogen from the air, break up compaction with deep roots, and add even more organic matter. Suddenly, farming wasn't just about extraction. It was about building soil health as an asset. But some farmers are now using complex mixes of a dozen or more cover crop species, mimicking natural prairie diversity. Others are integrating livestock, grazing animals on cover crops in a practice called integrated crop livestock systems. The animals add fertility, trample residue into the soil, and provide an additional income stream. These regenerative agriculture systems take the no-till principle and run with it, creating farms that improve over time rather than degrade. Yields stay high or increase, Input costs drop because healthy soil needs less fertilizer and pesticide, and the land becomes more resilient to droughts and floods. It's the kind of holistic solution that sounds too good to be true, but the data backs it up. Let's talk about some real examples because this isn't just theory. In North Dakota, farmers dealing with some of the harshest conditions in American agriculture have embraced no-till at incredible rates. Fields that were losing topsoil to wind erosion are now stable. Organic matter levels, which had fallen below 1% in many areas, are climbing back up. Farmers report saving fuel costs because they're making fewer passes over the field. Equipment lasts longer because there's less wear and tear. Water use efficiency is better, crucial in a region where rainfall is unpredictable. These aren't small improvements, they're transformative. In Africa, where smallholder farmers face immense challenges from poor soils and climate variability, no-till systems adapted to local conditions are spreading. In Zambia, farmers using a technique called basin planting, where they make small permanent planting holes instead of tilling entire fields, have seen maize yields double or triple. The basins capture water, concentrate organic matter, and reduce labor. For a farmer working by hand, not having to till a whole field is a massive advantage. This is the 9-inch principle adapted to a completely different context, but delivering similar benefits. Australia's experience is particularly striking. Much of the continent's farmland is fragile and prone to erosion. Australian farmers were early adopters of no-till, driven by necessity. Today, over 80% of Australia's cropping land is under no-till or minimum till systems. Researchers there have documented remarkable recoveries in soil structure and productivity. They've also pioneered controlled traffic farming, but where machinery always travels the same paths, leaving most of the field uncompacted. Combined with no-till, this creates soils with incredible structure and yields that keep improving year after year. The expert community, which initially resisted or dismissed no-till, has largely come around. Universities now teach it as best practice in many contexts. Government agencies promote it through incentive programs. International development organizations include no-till in climate adaptation strategies. It's become clear that this isn't a fringe idea anymore. It's mainstream, evidence-based agronomy. But here's the kicker. The experts didn't solve this, farmers did. The researchers and agronomists helped refine and spread the practice, sure. But the breakthrough came from farmers willing to question conventional wisdom and try something radically different. There's a deeper lesson here about how innovation happens. Sometimes the solution to a complex problem isn't more complexity. It's stepping back and asking whether you're solving the right problem. For decades, the question was, how do we make plowing work better? The real question should have been, do we need to plow at all? That shift in perspective, that willingness to challenge a fundamental assumption, that's where the magic happened. And it wasn't a scientist in a lab who made that leap. It was farmers observing nature, experimenting on their own land, taking risks, and sharing what worked. The 9 inches we're talking about represent something bigger than a measurement. It's a metaphor for how small changes in approach can have enormous impacts. It's a reminder that traditional practices aren't always best practices just because they're traditional. It's proof that sustainability and productivity don't have to be opposing goals. You can farm in ways that build soil, store carbon, protect water, support biodiversity, and still produce abundant food. In fact, in the long run, you produce more food by farming this way because you're working with natural systems instead of fighting against them. Looking forward, the principles behind no-till are influencing agriculture in ways that go beyond tillage itself. Precision agriculture technologies now help farmers manage fields at incredibly fine scales, applying inputs only where and when needed. Drone imagery and soil sensors provide data that would have been impossible to gather before. Genetic improvements in crop varieties are being tailored for no-till systems, with traits like better early vigor in cool soils. The whole system is evolving, and it's exciting to watch. Some researchers think we're on the edge of a new agricultural revolution, one based not on extracting more from the land, but on understanding and enhancing the natural processes that make soil productive. There are still challenges, no question. Climate change is making weather more unpredictable. Pest and disease pressures are shifting. The global population is still growing, and we need to feed everyone. But the no-till story gives reasons for optimism. It shows that farmers are incredibly innovative when given the right incentives and support. And it demonstrates that ecological principles and economic success can align. And it proves that solutions to even the most stubborn problems are possible if we're willing to think differently. So what's the takeaway from all this? If you're not a farmer, you might wonder why you should care. Here's why. The food you eat depends on soil. The stability of the climate depends partly on how we manage land. The health of rivers and ecosystems depends on farming practices. When farmers figure out how to do things better, it affects everyone. Supporting systems that reward soil health, whether through the food you buy, the policies you vote for, or just understanding and appreciating the complexity of agriculture, that matters. The 9-inch solution isn't just a farming success story. It's a human success story about problem solving, perseverance, and working with nature instead of against it. And maybe there's something in your own life, some problem you've been tackling the same way over and over without success. Maybe the solution isn't to try harder with the same approach. Maybe it's to question the approach itself, to look at what nature does, what the simplest option might be. What happens if you flip your assumptions? That's what those farmers did. They stopped asking how to plow better and started asking whether to plow at all. 9 inches. That's all it took to unlock a transformation that experts couldn't achieve with all their technology and research. Sometimes the biggest breakthroughs come from the smallest shifts in perspective. This story also teaches us something important about the pace of change in agriculture. Farming practices are deeply rooted, sometimes quite literally. They're passed down through generations, embedded in equipment investments, supported by established supply chains, and reinforced by regulatory frameworks. When a farmer has spent hundreds of thousands of dollars on conventional equipment, switching to no-till isn't just an agronomic decision. It's a massive financial and psychological commitment. Yet despite all these inertias, the shift happened. Not overnight, but steadily, gaining momentum decade after decade. That resilience in the face of entrenched systems tells us something about human adaptability when the benefits become clear enough. The economic transformation has been equally striking. Early adopters of no-till faced skepticism from neighbors, struggled with unfamiliar equipment, and often experienced a few lean years during transition. But those who persevered found themselves with significant competitive advantages. Fuel costs dropped because fewer tractor passes meant less diesel burned. Soil compaction decreased, meaning equipment didn't need to work as hard or require replacement as often. Fertilizer needs often declined because healthier soils with better structure and more biological activity made nutrients more available to plants. Over time, the profitability gap between conventional and no-till operations widened dramatically in favor of no-till. That's powerful. It means farmers didn't have to sacrifice income to farm more sustainably. They actually improved it. But there's another dimension that's often overlooked. The quality of life for farmers improved too. No-till requires fewer passes over the field, which means fewer hours in the tractor cab during critical seasons. Labor demands shift and often decrease. Farmers report having more time for their families, more flexibility, less stress. Agricultural burnout is real, and anything that reduces the physical and mental toll matters. The 9-inch solution indirectly addressed that too. When people ask why farming practices change, they often think about yields or costs, but never underestimate the human element. Farmers want manageable lives, and no-till helped deliver that. The environmental benefits extend far beyond carbon sequestration, though that's significant enough on its own. Water quality improvements are dramatic. When soil has good structure and is covered with residue, rainfall infiltrates rather than runs off. That means less erosion washing topsoil into streams, less nutrient runoff causing dead zones in rivers and coastal areas, less sedimentation choking waterways. Farmers practicing no-till have become unlikely environmental heroes, cleaning up water systems without necessarily thinking of themselves that way. They're just farming in a way that makes economic sense and happens to be better for everything downstream. Biodiversity changes are fascinating too. Conventional farming creates monocultures, bare ground for part of the year, and heavy pesticide use that wipes out non-target species. No-till fields, especially those with cover crops and crop rotations, support far more diverse communities of insects, soil organisms, and birds. The residue on the soil surface provides habitat. The living roots of cover crops feed fungi that support everything from ants to earthworms to beneficial predatory insects that eat crop pests. Over time, fields transition from ecological deserts to functioning ecosystems that still produce food. You don't sacrifice productivity, you actually gain resilience through biodiversity. Research into soil biology has accelerated thanks to the interest in no-till. Scientists have mapped the incredible complexity of soil microbial communities. We now know that a single handful of healthy soil contains more organisms than there are people on Earth. Different microbial species form networks that look almost like plant root systems. Fungi break down organic matter, bacteria fix nitrogen, protozoa graze on bacteria and release nutrients in plant-available forms. It's staggeringly complex and beautiful. Understanding this has led to innovations in how farmers manage their soils, introducing beneficial microorganisms through compost or managing conditions to promote naturally occurring ones. Soil science has transformed from a relatively static field focused on chemistry to a dynamic biology-centered discipline. The adaptation to climate change implications are becoming increasingly important. Extreme weather events are growing more frequent. Severe droughts, intense rainfall events, unexpected frosts, and shifting growing seasons challenge conventional agriculture that's often optimized for average conditions. No-till soils with good structure and high organic matter are more resilient. Better water infiltration means fields can handle intense rainfall without flooding or erosion. Higher organic matter means more water-holding capacity for drought tolerance. Root systems aren't damaged by compaction from constant tilling, so plants can access moisture deeper in the soil profile. Healthier soils mean healthier, more vigorous plants that can better withstand pest pressure and disease. As climate uncertainty increases, the buffering capacity of well-managed no-till systems becomes increasingly valuable. There's a growing movement now toward what's called regenerative agriculture, which takes no-till as a foundation and layers on additional practices. Diverse crop rotations instead of monocultures. Cover crops between cash crops. Reduced synthetic input use favoring biological solutions where possible. Integration of livestock when it makes sense. So the goal isn't just maintaining productivity, but actively improving land health year after year. Some regenerative farms measure success not just by yield, but by metrics like soil organic matter, infiltration rate, aggregate stability, microbial biomass, and biological diversity. They're farming for the long term, building natural capital that generates returns indefinitely. This shift in thinking reflects a maturation of our understanding. For much of modern history, we treated farming as mining. Extract nutrients, sell them as crops, deplete the soil, move on or compensate with more inputs. That's a linear extractive model that inevitably leads to degradation. Regenerative agriculture flips that perspective. It's cyclical. Build soil health, use that health to grow abundant food. Reinvest part of the organic matter and nutrients back into the soil, and the system gets better over time. It requires thinking in terms of decades and generations rather than quarterly profit statements. But increasingly, evidence shows that this approach delivers better economic results even on shorter time horizons. The 9-inch principle has influenced policy too. Agricultural incentive programs now favor practices that build soil health. Carbon markets are emerging where farmers can earn credits for sequestering carbon in their soils, essentially getting paid to improve their land. Some governments are subsidizing cover crop adoption. Universities are shifting their extension programs towards sustainable practices. Banks are more favorable to loans for farmers implementing conservation practices because they see the economic logic. But the infrastructure that supports agriculture is gradually reorienting toward rewarding regeneration rather than extraction. There are still regions and situations where the transition remains difficult. In large-scale commodity operations focused on maximizing individual crop yields in the short term, the mindset shift is hardest. In regions with particular climate challenges or pest pressures, conventional approaches sometimes still make sense. Different farming systems will likely coexist because one size doesn't fit all, but the direction of travel is clear. More farmers are choosing to work with soil rather than against it. The momentum is real and building. What's perhaps most remarkable is how this story unfolded without a charismatic leader or a specific moment of eureka. There was no single innovator who invented no-till, and instead it emerged from hundreds of thousands of farmers experimenting, observing, learning from nature, and sharing knowledge. Some innovations spread through farmer networks and informal knowledge sharing long before academic research validated them. This is crucial because it reminds us that expertise isn't only found in institutions. Practical wisdom exists in communities, in hands-on experience, in the accumulated observations of people working directly with natural systems. Dismissing that in favor of credentials and credentials alone would have meant missing solutions that were sitting right in front of us. If you've gotten this far, you might be starting to see why this story captivated me. It's not really about plowing depth or soil biology, though those are fascinating. It's about how humans solve problems, and how change happens despite resistance, how simple ideas can transform entire industries, and how working with nature instead of against it often turns out to be the smartest strategy both ethically and economically. It's a blueprint for problem solving that applies far beyond agriculture. So before we wrap up, I want to circle back to something I mentioned at the beginning. 9 inches seems impossibly simple to be the key to such transformation, but that simplicity is part of what makes it profound. Sometimes the biggest barriers to change aren't technical, they're perceptual. We get locked into ways of thinking about how things should work. Experts build their reputations on certain approaches. Industries profit from particular systems. Changing course requires not just new information, but willingness to question fundamental assumptions. The farmers who pioneered no-till did exactly that. They looked at conventional farming and asked whether it was actually solving the right problem. That simple question opened the door to everything that followed. And that's really what I hope you take away from this story, whether you ever farm a single acre or not. When you encounter problems in your own life or work that seem stuck, that resist conventional solutions, that keep reproducing despite everyone's best efforts, sometimes the answer isn't trying harder with the same approach. Sometimes it's stepping back and asking whether your fundamental assumption about the problem is correct. Maybe you're trying to solve the wrong problem. Maybe the answer is simpler than the complex systems you've built around the existing solution. Maybe the answer is in the opposite direction from where experts are pointing. Nature often works with elegant simplicity. The farmers who figured this out were just learning to listen. Before you go, if this kind of exploration into how the world works, how problems get solved, and how seemingly small changes create massive impacts speaks to you, please do hit that subscribe button. We dive deep into these stories all the time, uncovering the hidden logic behind things that seemed impossible until someone figured them out. There's so much fascinating history and innovation and human ingenuity in the world, and there's nothing I enjoy more than sharing it with people who are curious. Thanks so much for watching and for sticking with me all the way through this one. I really appreciate it, and I'll see you on the next one.